What's going on, everybody? This is Mr. Diamond. Let me move the mic a little bit closer. And this is the example video for balancing redox reactions in acids. And the way that you know that something is up involving acids, well, first of all, as the problem will tell you. But second of all, notice that this side has O's and H's, and this side does not have any O's and H's. But we are first going to go ahead and figure out our half reactions. That's the first step for all of these. The only difference is that normally with our half reactions, we just pulled out the pieces that we cared about. But this time we're actually going to pull out every single piece. So looking at our formulas here, we've got Cr, we have O, we have H, and we have S. Cr on the right side must be a +3. S on the right side must be a 0. H on the right side, or on the left side, is attached to a nonmetal, so it's got to be +1. There are no H's on this side. O over here has to be a -2. There are no H's on this side. So this tells us that we know our O and our H are not the thing we're actually looking at for our redox reaction. We got to be looking for our Cr and our S. So looking over here, if our H's are +1, our S must be -2. And if our Crs are, or if our O is -2, that's -14. We have -2. We want to get to -2 from -14. We would need +12, and there's 2 of them. So it's going to be +6. Okay. So then what we're going to do, we're going to write our half reactions just like we have been, except, like I said, we're going to actually leave the thing as a whole. So my first half reaction, let me make sure I'm in frame. Okay, good. We are still in frame. So my first half reaction, I'm going to do my Crs. So we're going to go Cr2O72 minus becomes Cr3 plus. And then way over here where I've got a bunch of space, I'm going to go ahead and label, it went from a +6 to a +3. Oxidation is lost, reduction is gain of electrons. So this is my reduction half reaction. And that must mean my other piece must be the oxidation half reaction, and my other piece is H2S becomes S. So what we did previously, if we look back, if you've got the notes written down from the step-by-step instruction, we just kind of went, okay, well now let's balance the charges. But now we actually have whole elements that are missing from each side. So we're going to start by writing the unbalanced half reactions, which is what we've done. That's step 1. And step 2 is we're going to balance our equation by adding H pluses and H2Os as needed. So we can add them to either side. We don't have to care about doing it to both sides in this case. So the easiest one down here is this. H2S gives S. That means we're going to have to include 2 H pluses. There's got to be 2 extra hydrogens on that one. Okay. And then the other one's a lot more difficult, but what we can do instead is we can say, well, there's 7 O's. I'm just going to go ahead and start by, the only way I can add O's is by adding 7 H2Os, or 7 waters to that side. That's going to give me 7 times 2 is 14. That is a large amount, but it's going to give me 14 H pluses. So we're going to add that to the left side. And then, only after we've done that, do we go back and we check our charges. You remember we had to make our charges equal by adding electrons to each side as needed. So we're going to go ahead and we're going to add electrons to each side to make our charges equal after we've added our waters and our hydrogens. So in this case, we have no charge over here. We have 2 positives over here. We're going to have to add 2 electrons to the right side. And then for the top one, we're going to have to add electrons to the left side. We know that because it's reduction and because we know that we can only add electrons to opposite sides. In this case, we have 14 positives and a 2 negative, so that's +12. Then we have a +3 over here. But looks like I missed something. We had to make sure we balanced adding as needed, which means we actually need a 2 right here. Totally left that out. So I mentioned we didn't need to do that up to this point. This is me being a little bit rusty on it. These snow days have messed me up a little bit, but we have to make sure that it's balanced, adding them as needed. We still have to make sure it's actually balanced. So the fact there's 2 CRs over here means we have to make sure there's 2 CRs over here. So now we have 14 positives, -2, that's +12. We have +6 over here. So we need to get +12 to +6. To do that, we're going to also have to add 6 electrons that are negative. All right, once you have this, it's a lot bigger than the ones we used before, but now it's the same process. We need to get the electrons to cancel out, and then we're going to add all of our stuff together and cancel anything that's the same. So you have 6 electrons on the left here, we have 2 electrons here, which means we're going to have to multiply this whole bottom piece by 3. And we then add everything together. I'm going to write it twice, so I can write it the full thing with all of the pieces intact, and then I can cancel out as a whole second step. So I've got 6 electrons, 14 H pluses, Cr2O7 2-, and then I have 3 H2S's. And then on the other side, I've got 3 S's. I've got 6 H pluses, I've got 6 electrons, I've got 2 Cr3 pluses, and I have 7 H2Os. So you can see it is much longer this time, but now we can go through and we can cancel out. So I'm going to get a couple of different colored pens over here so I can use them. So I've got H's on both sides. I've got electrons on both sides. So those are the 2 things that I'm going to be able to look at for canceling. My electrons are going to cancel, and if you did it right, your electrons should cancel. You should end up with no electrons left over. And now you also should end up with your hydrogens, or they should only be going to one side. And notice it's going to be the side that won't have any waters. You should end up with hydrogens on one side, waters on the other side. In most cases. I think there's probably like a corner case that would prove the exception to that. But in most of the problems, you're going to end up with a situation like that. In this case, though, we're going to take away all 6 of these, and that's going to reduce this by 6. That's going to reduce it to 8 hydrogens. And then we have everything canceled out that we could have canceled out. And I'm going to rewrite it just so it's neat. So we're going to have 8 hydrogens plus Cr2O7 with a 2 negative plus 3 H2S gives 3S plus 2 Cr3 plus 7 H2Os. And if we double check here, 8 pluses, that's +8, minus 2 is +6. The only charge on this side is this +3, and there's 2 of them. That's +6. Our charges have stayed identical. Even though we've canceled a whole bunch of stuff out, your charges should still end up being the same. So this right here is the balanced redox equation for Cr2O7 plus H2S gives Cr plus S in an acidic medium. We have to add hydrogens and we have to add waters to be able to get it to balance out. Okay, that's what I've got for this video. There should be another video that'll be attached to this that's got the basic examples of how you do them with bases. It's the same process. You're just going to be adding in kind of one little extra step in it. So this is Mr. Diamond signing off. Send me an email if you have any questions. In the meantime, though, have a great day, everybody.